Franco from here.
So, hi everyone, my name is Caroline. I am a PhD. Sorry.
Yeah, all right, the mic.
Check if it's on. Yeah, it's on.
Yeah. It's just a bit difficult. Okay. So my name is Caroline. I'm a PhD student here at the Institute for Theoretical Physics. I work under supervision of Professor Roberto Franco. And I'm in the middle of my PhD, so I'm going to talk about my ongoing work, my perspectives. I'm interested in vector-borne diseases happening in Brazil, so mostly dengue and malaria. And most of my work until now was regarding collecting data to do analysis and understand the dynamics of these diseases. So as you know, we already talked a lot about it. Dengue happens all over Brazil, and we have found data at the municipality level in Brazil, data that came from the Ministry of Health. We took some time to understand how to get this data. So if any of you want this kind of thing, you need to go to the government website and request the exact kind of data you want. In our case, we have anonymized case-by-case data for notifications. For all dengue-like diseases, it's interesting that we also have serotype data. It's not, they don't always test for serotypes, for example, but for like 1% of cases, there might be this kind of information. And this is the kind of thing we have. And also, we were looking for meteorological data. So we found for some municipalities, things like maximum and minimum temperature, precipitation, and like Carrie knows, it's really difficult to find this kind of data for the whole country. So we can fight for a few cities, but sometimes data has like weeks of missing measurements, or you can find better data for some other city, but it doesn't have all the variables. So we are kind of still dealing with this kind of problem. But we already started doing the aggregation of this data. So for example, we had notification data, and then we already have time series, weekly or yearly or monthly for dengue and malaria. And also we have some data on these meteorological variables. So we had many ideas of what to do with that, from machine learning to modeling. But one of the things our group is more focused on is using the empirical dynamic modeling framework that you already heard about, which is a way to try to extract causal links from data between two sets of data. So and we use an already implemented R package developed by Sujihara Lab. And we try to make this kind of studies similar to the studies that Renato showed for malaria in Argentina. We are trying to do something like that for dengue in Brazil. So we want to use meteorological data and cases of dengue throughout Brazil, and try to find some kind of pattern between these variables. This is, like I said, ongoing. And this is the kind of thing we are doing for dengue right now. And another part of my work or my interests is regarding malaria. So we also have data. I also spent a lot of time in this data processing. We also have notification data for all over Brazil. Actually, in this case, it's separated in two databases, one for Amazon region, another one for the rest of the country. And this is important because 99% of malaria cases happen in Amazon region. And so I worked with these two databases, made some work aggregating it, the same kind of request we went through. And this part of work I do mostly, or I will do mostly in collaboration with Lisa. It started a few years ago when we started to do some deterministic modeling. Now we have data to try and fit the model and make better predictions. Actually, in the dengue project, we are more focused on understanding the dynamics and making better and better predictions. In this case, as you see, I'm more interested in exploring different scenarios and explore which kind of intervention would be better. So the kind of thing we do is compartmental modeling, like some kind of extended SIR model. So we have susceptibles, recovered, and different types of infected individuals. If you are talking about Plasmodium vivax, you are going to have also an immunocyte state. We include the dynamics of it, the population dynamics. So lots of considerations about the malaria dynamics, which we know is pretty complicated. Just for you to have an idea, for Plasmodium falciparum, this is the kind of baseline model we have. So we have this 5 compartments, and we have like this flow between compartments. And the kind of thing we want to do is to also model the dynamics of treatment, how treatment affects the dynamics of the disease. And so, and this is a way to model interventions. So not only adding the treatment and another recovered but under drugs compartment in the system, but we can also play with the parameters to model the interventions for different coverage or effectiveness of the interventions. If we have PV or vivax malaria, it's a bit more complicated, like I said, because there is an extra compartment for the latent state that leads to relapses. So the model is a bit more complicated.
Does everyone get that kind of latent state who gets vivax, or is it only some fraction of the people?
In Brazil?
Just in general for vivax, do they all go to
to relapse?
Or, yeah, or
no, there is a
relapse,
probability of going to this latent state, but if you get treated, because this state happens in the liver stage, so if you get treated early enough, you won't get to this stage, so relapses can't happen. I mean, if the treatment works, yeah. So we can also model treatment and interventions for this in this context. like I said, to model an intervention, you can it can be in the sense of treatment, like I said, adding a compartment and the dynamics of treated people, or you can, for example, change the force of infection or the effective contact rate as a function of the effectiveness or the coverage of these interventions, like vector control. And this is the kind of output we have. We try to adjust the parameters to have the to find some kind of dynamics that matches what has already happened, and we try to play with parameters like compliance and coverage of interventions to see which has a better efficiency, for example. One thing that we also want to do, or we already started, is doing something more visual and interactive. So when I first started working with that, we produced this nice interactive platform where you can play with the parameters to see what changes in the outcome of the model, like coverage, biting rate, everything related to the model you can change and see in real time what happened. And that's basically it. I just wanted to talk about my perspectives. So most of my time I've spent processing the data, understanding what is there, because sometimes we have 100 variables, 100 columns to understand, and we need to go through data dictionaries, things like that. And this was a lot of work, but it's nice that things are getting more organized. I organized already a repository with dengue data. This is like, I think this is weekly time series that I have in there. But I plan to organize everything I'm doing in these public repositories, like also for malaria, I'm also doing that. So if you want to more information about this data, or if it is not in the format that you expected, we can just chat so I can organize it, and this is the link, but you can also contact me by email. And well, I think that's it.
Thank you. Oh, questions? Yeah, sorry.
Is the interactive app for only one city, or are you doing it for different cities?
Yeah, in that case, it was like a preliminary model. So it was just like the first model we had for both PF and PV in Brazil, but not all the parameters are specifically correct. We didn't feed the model with actual data yet, so that's my next step. So that one is not for a specific.
It's just a toy model?
Yes, kind of.
Okay.
I still need to work on that, yeah.
Yeah, I just want to point out that Caroline did that in how many weeks?
I don't know, well, 1 month.
Yeah.
Yeah, 1 month.
Good job.
And also, I'd like to make a suggestion that you quickly write papers, if you haven't already, on the data sets that you've
That's the plan,
organised.
yeah.
So that when people, I think it's fantastic that you're sharing them,
Mm-hmm.
but when people do make use of that resource, they're able to credit you with the work.
Yes, yes. Yeah, I actually chose a repository that has a DOI, so you can cite even if I don't have a paper yet. But yeah, that's the plan. We just need time
And
to.
there are journals now where you can just publish data.
Yes.
Yeah.
You don't have to publish the paper, and so that
Scientific data.
Mm-hmm.
yeah,
Fantastic.
data journals.
Yeah.
Yeah,
It's so nice to have it as a shared resource.
yeah, absolutely.
Yeah.
Absolutely.
So,
Caroline,
any data on estimates of treatment dropout for malaria patients?
No, we really wanted this kind of data, but yeah. What I have is CVAP, SISMO, and
Yes.
SINAM data. So,
Ah.
yeah.
You say that the malaria is in the Amazon basin. It's because the vector is there, not in the rest of Brazil, or why? It's only in the...
I think malaria happens in that kind of climatic environment, and also it's near the forest, and the vector happens throughout Brazil, but it is most concentrated in Amazonian region. Yeah.
It's probably climatic too.
Yeah.
Because you need a certain
Environmental
certain temperature for transmission.
and the landscape also, the environmental
Yeah.
landscape.
So it's
It's not like bluebird mosquito.
and there must be
It's not a problem.
No, they like the forest
They
and
like the forest, and then you
they
have
bite
the
at night, so they need people not sleeping under bed nets or in, you know, houses.
There's a lot of malaria going on in the border of the forest. You need also humans. In the forest, there's malaria. But it's something connected with borders.
Yeah.
But during sevens, we also had a lot of malaria in the northeast part, and was another vector in that area. And they could control the vector and eliminate in that area.
Where?
In the northeast.
I don't know.
Yeah. It was a bit different. And just one comment, like you said about evaluating different interventions and drug treatment. Brazil is now trying to introduce a new drug treatment that is tafenoquine.
Yes.
Which is a single dose and will take the place of primaquine. That's 7 days regimen.
Yeah. So you have higher adherence to
Yeah,
treatment.
people are expecting you have higher adherence, but this is like there are some things behind it, because there is one work that was presented in ASTMH last year in the Congress in Maryland that shows that for 14 days primaquine is more effective than 7 days primaquine, and then they compared the 7 days primaquine with tafenoquine, and they say that's the same, that's then it's not the most, it's not the best regimen, yes, but it's a
Yeah,
very,
I think that's the kind of thing we could try to model.
yeah, definitely, it's a very, very good time for this.
Yeah.
Do you need to be Brazilian to make a request for data?
Actually, yes, because you need your tax number.
Oh, okay.
So you have to be Brazilian. That's very yes.
Yeah.
But if you really want, I can give you mine.
Nobody was there.
Yeah.
Can someone share their tax number with us?
Actually, there are lots of other diseases you can get from this.
Yeah, all notifiable. I mean, this is just the freedom of information. It's being used filing things to the Ministry of Health, or you could actually all the notifiable diseases you can.
But there are a lot of details, right? So it's you cannot just go there and say, give me all the data you have about
And
this.
you have to know how to ask.
You have to know the information they do have in order to ask that.
So an example, you want the table like that.
And if they don't have it, they just say, we don't have
An
that.
example
Yeah,
of
because
table with the variables, and he asked for that.
If you ask about data, they would say kind of no, don't have those.
Okay.
No, because they give you the raw data, and actually they don't will do any processing. It's not their job. They just give the data anonymous, without address and without name. But the rest you have to find your way out to treat this data. It's that. So, thank you again. So, time for our grand finale. So, Gabrielle.